Hey Calculus class! Tonight we are going to learn topic 40, integration of partial fractions. So let's first do a quick review of partial fractions. So for partial fraction composition, this means that we are finding a common denominator or rewriting multiple fractions into one big fraction. So, for example, we have two separate fractions being added together, and we want to compose them together into one big fraction. So we want to find a common denominator. And that common denominator is, of course, each factor of the bottom. So I had to multiply the 5 by x plus 1, and I had to multiply the 8 by x minus 4, and then I could add them together. And I could even simplify it, so distributing and combining like terms, so that I get the following final fraction. Now, this is a skill that you have been doing since elementary school. You have been adding fractions with different denominators and having to find that common denominator. That's nothing new. Now, in math analysis last year, you learned how to decompose a fraction. They're called partial fraction decomposition. So, this means that we are going to do the inverse of finding the common denominator, or we are just breaking up a fraction into multiple fractions. So we'll see how many of you guys remember this. So we're going to still use our same example, 13x minus 27 over x squared minus 3x minus 4. So step 0 is only a step if you need to use it. If the degree of the numerator is bigger than the degree of the denominator, you must use long division to rewrite the fraction as a polynomial plus some other fraction. Luckily, the degree in the numerator is smaller than the bottom. Phew, no long division right now. So step 1, we want to factor the denominator. So I can factor x squared minus 3x minus 4 to give me factors of x plus 1 and x minus 4. Now step 2 is to break the fraction into two or more fractions being added, putting letters on top for the unknown constants. So I have some numerator over x plus 1 plus some other numerator over x minus 4. So I split up the factors on the bottom. Step 3, we are now going to recombine the fractions by finding the common denominator. So I'm going to take these two separate fractions, just with an a and a b on top, and I'm going to find a common denominator, which is the x plus 1 times the x minus 4. So I'm going to multiply a by x minus 4, b by x plus 1. Now step 4, you are going to rearrange the numerator by grouping like terms. So first thing, we're going to take our numerator and we're going to distribute through first. Now I'm going to group like terms. So what I mean grouping like terms is I'm going to group the x terms together and I'm going to group the just constants, because a and b are just some constants. So now I have ax plus bx minus 4a plus b. And then I can factor out an x in my first grouping. So I now have a plus b times x. Now I'm going to equate the coefficients and use a system of linear equations to solve for the letters a and b. So if we remember our very beginning, this was our numerator, the 13x minus 27. This has to equal this numerator in terms of a and b. Well, the x term has an a plus b. This x term has a 13. So therefore, I can say that a plus b has to equal 13. And then the minus 4a plus b, that's just some constant. Well, that has to equal my other constant over here, negative 27. So here are my two equations. Now I'm going to use a system of linear equations to solve for a and b. Usually, you'll probably just use substitution. So I'm going to solve for one of the variables in the first equation. So I solved for b. You could solve for a. Doesn't really matter. Go ahead and plug the 13 minus a in for b. So I have negative 27 equals negative 4a plus 13 minus a. Now I can go ahead and solve for a. So I'm going to subtract the 13 from both sides and combine the a's so that I get negative 40 equals negative 5a. Divide both sides by negative 5. So now 8 equals a. Now I can go ahead and find b. b is equal to 13 minus a. So 13 minus 8 is 5. So then I can finally write my decomposition of the fractions. So this one big fraction can be split up into these two smaller fractions. All right. Example with long division. So what if you have to do step 0? All right, so here's an example of a fraction where the degree of the numerator is bigger than the degree of the denominator. So when this happens, you have to do long division. So let's see if we remember long division. You want to put the numerator underneath the long division sign. And of course, don't forget the terms that you don't have up here. So you have to put the 0 in front. And then your denominator is what you're dividing by. All right, so the first thing you do, if we can remember, is that you are going to divide the first term underneath the division sign, so x to the 5th, by the first term that you are dividing by, x cubed. So x to the 5th divided by x cubed gives me x squared. So I'm going to put that x squared over its like term, which is the 2x squared. Now, just like normal long division, you are going to multiply this term by what you're dividing by. So x squared times x cubed gives me x to the 5th. X squared times negative x gives me negative x cubed. Then you subtract. So that makes this a minus, and this becomes a plus. So now the x to the 5th cancel. Can bring down what I have, which just gives me x cubed. Next step after you add or subtract this part, you bring down the next term, that 2x squared. Now I'm going to do the same thing like I did before. Take the first term, x cubed, divide it by the first term in the divisor, which gives me 1. So I put it over the constant term. So then I'm going to multiply the 1 through. So I get x cubed minus x. Subtract, so that now I have x cubed minus x cubed, so those go away. Bring down that 2x squared, and then 0x plus x just gives me x. And then I can go ahead and bring down my next term, which is plus 1. Next step would be to do 2x squared divided by x cubed. But that would leave me with a negative exponent. So we are pretty much done doing long division. What you are left with right here is your remainder. So now you can rewrite this fraction as x squared plus x plus the remainder over your divisor. And this part right here is what you're going to do the partial fractions on. So this new fraction now has a smaller degree in the numerator, which is what we want. So we now can do partial fraction decomposition on this new fraction. All right, so let's go ahead and do it. First thing, factor the denominator. You can keep factoring. Then in this case, there are 3 factors. So that means I'm going to split this up into 3 different fractions. Now I can go ahead and find the common denominator. So I have to multiply each piece by the certain factor. Now I'm going to just focus on the numerator, and I am going to distribute stuff through. Keep distributing. now I'm going to go ahead and regroup this numerator. So the x squareds go together, so I can factor out an x squared. The x's go together, and then the constants. Now I can go ahead and equate this numerator with my original numerator from the beginning. And then I can let each constant for each term equal the a's, b's, and c's. So on the x squared, I have a 2, so that equals a plus b plus c. On the x, I have a 1, so that equals b minus c. And my constant is 1, so that means I have negative a equals 1. So now I'm going to head and solve. Now, of course, it appears that a is, of course, going to be the easiest to solve for. So a equals negative 1. Now I can go ahead and put negative 1 into a on the first equation and simplify that a little bit. So I have b plus c equals 3. So now I have b plus c equals 3 and b minus c equals 3. So now I can solve for either b or c in either equation. And I chose to do the second one. I solved for b. So I can put c plus 1 up here into the b plus c. So now I have c plus 1 plus c equals 3. Subtract the 1, combine the like terms, and divide. So c equals 1. And then, of course, to find b equals c plus 1. So 1 plus 1 equals 2. Now I have a, b, and c. So now I can go ahead and write my partial decomposition. From the very beginning, remember we had this one. After we did the long division, we had this. And then here is our final remainder. All right. All of this was a review for us to now be able to integrate partial fractions. So once you decompose the partial fractions, then you just integrate each term by using integration techniques. All right, so we're going to go back to our original example that we started with. We have already decomposed this. So step 1, decompose the partial fraction. We have already done this, so usually there will be a lot more work for step 1 than what I'm showing you now. We've already done that work. Now, separate the integrals and use integration techniques to integrate. So I went ahead and pulled out the multiple constants. And when I'm looking at these two integrals, I can use u substitution. So for the first one, u equals x plus 1, du equals dx. The second one, u equals x minus 4, du equals dx. So now I can go ahead and substitute in the u's, and whose derivative is 1 over u, the natural log of the absolute value of u. Now I can go ahead and replace u with the appropriate ones. So that first u was the x plus 1, and the second u was x minus 4. Now if there's too many u's, you could do u here, and you can choose a different letter here. You could choose w or v or t or whatever you like. Now, of course, technically you're done. But sometimes you would be given a multiple choice question, and this would not be your answer choice. So usually when that happens, you're going to have to use some log properties to simplify it to your answer choice. So we can use the power property of logs by bringing the 8 over and the 5 over. So I get the following. Doing that, if that still doesn't give you an answer, we have the log property that when you are adding two logs with the same base, that means that the arguments are multiplying in one log. So we now have this. So just keep in mind that you only need to simplify if it's a multiple choice question. All right, let's see if you can do this one all by yourself. All right, let's see how we did. First thing, we have to decompose this. So we have to factor the bottom, split this up into two fractions with one of each factor, and then you have an a and a b. Go ahead and find another denominator, or find another common denominator. Go ahead and in the numerator, distribute, combine and group the like terms, so the x's together and then the constants together. Now we're going to equate this to our original numerator, 2x. So for the x term, we have a plus b, so that's going to have to equal 2. Now we don't have a constant over here in my original numerator, so that means 2a plus b equals 0. I'm going to go ahead and solve for a or b in either equation. I actually chose the second equation because it's equal to 0 and it's pretty simple. So that means b equals negative 2a. Then I can go ahead and replace b in the second equation. So I have a minus 2a equals 2. Combine like terms, solve for a. So a equals negative 2. Now I can go ahead and find b. And so b is going to equal 4 because negative 2 times negative 2 gives me 4. So now I can rewrite my original fraction as 2 separate fractions. Now we get to do the calculus part. Now we can integrate. So separate the 2 fractions. Use u substitution. And of course you can also bring out the multiple constants. You can go ahead and use u substitution for each one. And then once you do the u substitution, you get the 1 over u. And that means the antiderivative is the natural log. Resubstitute in the u to get the following. Well, I hope you enjoyed partial fractions, and I will see you in class tomorrow. Have a good night.